In this lesson, we are going to continue our discussion on variables, and we are going to take a look at a few common errors that you may make while working with variables. Take a look at this program. Pause the video and try to spot the error, if any. Before I tell you about the error, let's go ahead and compile this program. Upon compiling, we received this error message. B was not declared in the scope. This indicates that B is not defined in this particular section of the program. But if we look closely in the program, then we can see that B is clearly defined on line 9 and even initialized to the value 2. Then what's going on? Why are we getting the error that B is not defined? We've clearly defined it at line 9. We already know that a variable must be defined before it can be used. In our example, all variables a, b, and c are defined. In fact, all of them are initialized to a certain value. Another important fact to keep in mind, if you're not already familiar with it, is that C++ code is read from top to bottom, which means statements that come first in order are evaluated first. Now from the error message, we know that the program thinks the variable b is not defined. So let's take a closer look at the code snippet and notice the first occurrence of the variable b. B first appears in the initialization of C. However, the first occurrence of variable should always be a definition or initialization of the variable. The expression a plus b is incorrect here because b is not yet defined. The program does not know of b yet to substitute a value for it. In fact, if you go back to the compiler error, then you'll notice that the line pointed by the compiler in the error message is line 8, where the initialization of the variable c is being performed and the expression a plus b is evaluated. B is highlighted in red. The compiler is telling us that b is not defined at the moment, which is why this is an error. Let's go ahead and switch these two things. First, let's define b, and then initialize C. Now that we've fixed the definition of B, we should be able to run this program without any hiccups. Let's go ahead and try this out. And there you go. The answer is 3 because A is 1 and B is 2, so the sum is 3, and when we print C, we simply get the result 3. Let's consider another example. In this example, we are simply defining 4 integer variables a, v, b, and x. Since they're all of the same data type, an integer, they can all be defined in a single statement separated by commas. Next, we are printing all of these variables onto the screen one by one. Following that, we are multiplying the variable x with 5 and storing the result in the variable x itself. And then finally, we are printing the value of the variable x. Take a look at this program and see if you can predict the result that will be printed on the screen. Let's go ahead and compile this program and then execute it. First 4 statements simply print the value of the 4 variables x, a, b, and v. Notice that there's a mixture of values in there, even though all of them were defined in the same statement. Why do you think that is? Then, once we multiply 5 with x and store the result in x, notice that 5 times a very small negative number is an even smaller negative number. However, when you notice the result of x, that turns out to be a large positive number. This is one of the reasons why uninitialized variables are not recommended. Uninitialized variables are one of the most common errors in C++. When a variable is declared, some memory space is allocated for the variable. Thus, the variable might already contain some garbage value. This value is generally unpredictable. Modern C++ compilers and standards may default to a certain value, and if you're lucky, you might get a favorable value assigned to your variable. But that value should not be taken as a standard value. An uninitialized variable is not a syntax error per se, but it may lead you into a runtime error due to unpredictable behavior, such as the value of the variable x in the example we just saw. You may not assume any safe value for an uninitialized variable unless otherwise specified in the documentation. For example, when we talk about strings in C++, we'll note that strings are always initialized to an empty string by default. However, integers are not initialized to any safe value. This concludes our lesson on the common errors while working with variables in C++.